Now, do the graph. Okay, remember, we studied last class the aim behavior. So the aim behavior expression is you take the expression that contains higher exponent. It's the aim behavior because it's the dominant, it's the monomial que increasing faster. Now, when you see that the exponent is an even number, and the coefficient, by the way, guess what, is positive number, the aim behavior guy, some students ask me, show the word. Well, show the word and the reading test. And the online test, no? In the online test, you put the answer. Okay? And you don't need to send me anything. Online is online. You're working online, I'll check it online. No paper. Cool? The aim behavior, the aim behavior, thank you. Look like that. Okay, in other words, right up, left up, because it's even. Are you clear this idea, right? Last time we discussed this in detail. Now, important, find the zeros. The zero is the x-unit set. And why not? Find the y-intercept. The formulas to remember, the mnemonic device to remember y-intercept is evaluate the function as 0. Entonces you take the original, evaluate 0 es 0 to the 4th power, minus 2 times 0 to the 2nd power, es obvio que es 0. Entonces ese coincidence que te pone 0,0 is the y-intercept. But by the way, is the x-intercept also because it's 0 above quantity, no? However, in order to find the complete collection of the x-intercept, you take the function and you enforce it to be 0. This is the formula, guys, for finding x-intercept, and this is the formula for finding y-intercept. Remember that. We use it throughout the course. So you copy x to the 4th power minus 4x to the 2nd power equals 0. Oh, this is easy by factorization. So in the factorization, you seek the GCF. So the greater common factor is x squared. And you factor out. So we have x squared minus 4 equal to 0. Okay, but I don't finish factorization because you have here in that part, you have the difference of the square, and the factorization is, copy this, bring down, open two new parentheses, square root, this is xx, and square root 4 is 2 plus or minus. So basically, I am using this famous formula, I suppose que everyone know very well. A squared minus b squared is a plus b times a minus b. Do you remember that? Do you remember that formula? Answer me.
Yeah.
Cool. Now, in this moment, I almost finished. The only thing you should do is copy each factor one by one, and you enforce it to be 0. This is 0 factor property. So say x squared is equal to 0, x plus 2 is equal to 0, and x minus 2 is equal to 0. Now the conclusion is, it's obvious that x is 0, and another x is negative 2, and another x is positive. But actually the important is, look, the degree of the original polynomial is degree is 4. And when the degree is 4, is this exponent, we have 4 solutions always. The problem is the multiplicity. So actually this 0 is multiplicity. Okay, multiplicity is the repetition. Multiplicity 2, because actually it's x squared equals 0. It's a quadratic equation, but You know, so you find the square root here is 0. It's obvious it's 0, but 0 have no sign, no plus or minus. Entonces, you can interpret que this 0 is like 0,0, it's 2 0, multiplicity 2. But of course, you don't write double 0. You write only 1 0 and you indicate the multiplicity 2. And negative 2, the multiplicity is 1 time only. And the second one is multiplicity 1 again. In conclusion, 1 plus 1 is 2, plus 2 is 4, que is exactly coincident with the degree of this. Now, the thing I want to illustrate is the aim behavior. You know the aim behavior. Look, this is the aim behavior. Let's try to do quickly, roughly, the sketch, and after we check it out in Desmos of the our problem. This is x-axis, this is y-axis. Important point was 0, 0. Because 0, 0 is both. Is y-intercept and x-intercept. But we have two more, okay, negative 2 and positive 2. Positive 2, this point is the point 2, 0, and this point is minus 2,0. Yeah, I know very well, very well that the graph of the that polynomial look like similar to this, because this is the aim behavior expression. And you have 3 points, and that's it. So I believe, using my common sense, que look like that. Another 0, and another 0. Notice que in the zeros in which the multiplicity is even number 2, 4, 6, the graph touch the axis. However, in the multiplicity 1, 3 is odd number, the graph cross it. This is important detail. Cross it and touch it. That depends only of the multiplicity of the 0. You get the idea? You get the idea? Yeah. Let's see.
So Professor.
Go ahead.
How does it touch it twice? I only see it touch it once.
Well, the one in this case touch it 1 time, because putting off the microphone. Because in this case we have only 3 zeros, no? Actually, this is this, and this. Entonces, yeah, I know the aim behavior. The aim behavior look like that. So we start a positive infinity up, but the part that you don't know, the part in the middle look like that. Cross it, the axis. In this case, I know that no cross it. No, it's touch it. Because I need to go again over and positive. So now another example you see. This is my first example in which you can see the different behavior, touch it or cross it. Okay, I promise we are doing 3,000 problems. In the review, we are doing 4,000 problems. Okay, entonces, you get the idea, no? The base idea, yes or no? Mister?
Yes, I get it.
Okay. I want to share quickly my Desmos, and you see the graphic in elegant way. Any graphic we are doing, we double checking in Desmos. Do you see my Desmos? Do you see or no? Look, it's example 2. Do you see? With the point?
Yeah.
Beautiful, eh? Any questions so far? Let's do one more. Similar, very similar. Very similar. No exactly the same, but similar. And obviously, after I want to cover another thing. And so far, one similar. You see my whiteboard? Yes or no?
Yeah.
I can erase, yes or no? May I?
Yes, sir.
Yeah.
Example 3. Example 3, we are doing exactly the same. It's a polynomial. The polynomial is given this equation. Okay. Suppose like that. No. 4. X to the 0. Okay, cool. Now, question number 1. What is the degree of this polynomial?
6.
Super. Get the highest one. What is the aim behavior expression? Remember, aim behavior expression for the student that don't, so in this moment, don't understand very well. You.
Up, right up.
It's what?
Left up, right up.
But what is the expression? So we have three. We have three.
Even positive.
But wait, relax. My question was aim behavior expression. Aim behavior expression, we have 3 monomials. 1, 2, and 3. Aim behavior expression represent the monomial increasing faster, que obviously always is the monomial que contain higher exponent. Yes or no? And this is the dominant.
Yes.
And looking this, you see exponent even coefficient positive because there's one invisible one, the end behavior look like that. Yes or no? Like when you ending similar to another problem. Guys, everyone follow me this idea?
Yes.
Okay.
Yeah.
Y and Z. S evaluate the function as 0, 0.6 minus 3 times 0.4 minus 4 times 0 squared. It's obvious que 0. And the point is 0.0, similar to the another example 2. Okay, in this case is when you see the 2 components are 0 because that point is y in z and also x in z. X in z is different formula, is f of x equals 0, que is x to the 6 minus 3 x to the 4 minus 4 x to the second equals 0. And you're solving this equation, polynomial equation, by factorization. So far, in a few seconds, in a few minutes, we're solving another way, more sophisticated. But so far, it's factorization. It's obvious that the GCF is equal to x to the second. Because it's a smaller exponent, I factor out, and we have x to the 4th power minus 3 x squared minus 4. I finish the factorization? No, because we have here one trinomial, and this trinomial, you break it down into binomial, que is x squared, que is the square root of this guy, and the combination in that case is 4 and 1. 4 and 1, no? 4 and 1, because 4 times 1 is 4, and 4 minus 1 somehow is 3. The corresponding sign are minus here and positive here. Now I finish, no? Okay, that was trinomial. Now, again, we have a difference of a square. Because here I saw a difference of a square. Okay, unfortunately, the sum of the square, so that one, is impossible factorization, a prime expression. Let's see what happened with this. Okay, this is now we continue factorization. I bring down x squared. I decompose this x squared minus 4 like x 2 plus and minus, and just bring down x squared plus 1. Okay, unfortunately, we can't do anything in this because this expression x squared plus 1, suppose that I try to do my best to find the solution. I move a -1 to the other side. You apply square root to say x is equal plus or minus I. Okay, you know very well a negative number inside the square root give me complex or imaginary. Therefore, this expression, the name is prime, or another name that everyone knows is irreducible quadratic expression. Okay, irreducible quadratic equation, I don't care. Do not apport because the solution is complex or is imaginary, and the complex and imaginary you cannot see physically in the real plane. So now conclusion, we have 3 factorial, this and this. I don't care this for a moment. Es obvio que x equals 0, multiplicity 2. Yes or no? X equal -2, que es that one. Multiplicity 1. And x equal +2, multiplicity 1 again. I need to know que multiplicity 2 even touched the axis, and this no, cross it. Okay, let me summarize because I don't understand something. The degree of the our polynomial is 6. Degree is 6. Therefore, we need 6 solutions, 6 zeros. We have actually 4 real. Okay, the real are 0 2 times multiplicity 2, so it's like you can interpret it like a 0,0, but when it's repeated, you don't need to write -2 and +2. 1, 2, 3, 4. 4 reals, and we have 2 more imaginary, positive I and negative I, que I don't care. I don't care. Y es totally irrelevant when you are doing the graph of the polynomial by hand. No, you never see this guy. Okay, so now how look like the graph of the our polynomial? Well, the graph of the our polynomial look like that. We have the point 0, 0, 0,0. We have 1, 2. It's very similar to another. And this is the 2,0, and this is -2. This is -2,0. And the behavior is like that. So it actually is something like the cross it, touch it, and cross it. But the new thing that brings me this example is that we have 2 more que es complex or imaginary, and the complex or imaginary you don't see in this plane, XY plane, in which both axes are real. This idea is clear or confusing? Everyone follow me? Answer me. Yes or no?
Yes.
No. Okay. What is the new thing we need to study in the polynomial function analysis? Well, we need to understand another way to find the zeros, because so far the only possibility we are doing is factorization, and factorization, you know, is very weak, not good, not always we can do that. However, I want to explain another more efficient way, okay, using division. You are doing division, and remainder theorem. This is super important, guys. Super important. Division and remainder theorem. Let me refresh your memory. Suppose you will have 2x squared, easy, plus 3x minus 14 divided by x minus 2. Okay, actually, we are doing the division 1 polynomial degree 2 at the top, divided by 1 polynomial degree 1 at the bottom. And the efficiency way to do this is using long division. You copy 2x squared gets the dividend. You copy outside the divisor, and you start the long division. It's easy because I need to find one expression can multiply by x, so one expression in one box. One expression, I have no idea. Can multiply by x, give me 2x squared, get the first one. Entonces es obvio que es 2x, because 2x times x, this times this, is 2x squared, exactly the same. Wow, fantastic, I like that. And this multiplied by this. Entonces minus 4x. 2 times negative 2 and negative 4. No, by subtracting, you change the sign. You say, bueno, professor, why I need to subtract it? Because you know que division is the algorithm que es multiplication subtraction. Let me explain quickly. 5 divided by 2 is 2. 2 times 2 is 4, subtracting, remainder 1. So multiplication is ese algoritmo que es systematic multiplication and subtraction, multiplication and subtraction, multiplication and subtraction. That is the reason that I change the sign. Now, always intentionally, I did that. This part is canceled, 0, and this is 7. So 3 plus 4 is 7. Bring down negative 14. How do you know that you need to bring down this? Well, because you finish when the hypothetical remainder, okay, is this guy, the degree is less than the degree of the divisor. This is divisor. Divisor is this guy. And by the way, the degree of the divisor is 1. Exponent 1. Now the degree of this hypothetical remainder is 1. Entonces no, we have to continue. We stop when you get hypothetical remainder degree 0. So less than 1, the degree of the divisor. So you need to continue. So now is you copy one expression, can multiply by x again, give me 7x, get 7. 7 times x is 7x, and 7 times negative 2 is negative 14. And by subtracting, you change the sign and you get remainder 0. Not always you get remainder 0. But when you get remainder 0, this is the famous remainder theorem. That means that the factor, look, 2x squared, I discover mathematically that this division is equal 2x plus 7. Okay, by the way, it's equivalent to say, if you apply cross multiply, you multiply this times this, the 2x squared plus 3x minus 14 is equal 2x plus 7 times x minus 2. But actually, we are doing the factorization not by the classical factorization, using this division. But I have more. This is a long division. I like that. It's good. But we have one version, easier, okay, scientific division. It's similar, but scientific division you can use it only when the degree of the divisor is 1. When the degree of the divisor is 1. That's the way. Okay, we can use scientific division. But what is the algorithm of the scientific division? It's similar to the long division, but it's easier, super easy. Let me try to copy here. You open again our famous symbol of the division. You copy only the coefficient from the polynomial, case 2, 3, and negative 14, and you omit the x. Actually, you know, the reason you omit is because you know very well okay, this is x squared, and this is x1, and this is x0. Because 14, actually, we have no x. Okay, but this is the default idea, you don't need to write. But the only new situation is that you divide by x minus 2, but you copy only 2. Oh, professor, I don't understand. You delete x and you change the sign of this. Yes. Why? Because automatically you are doing one time the change of sign. You don't need to do like a long division that you subtracting, change the sign, subtracting, change the sign. So no, you say change the sign one time at the beginning and that's it. Look, let me show you. You bring down this first without do anything. A multiplication 2 times 2 is 4. And 4 plus 3 is 7. A multiplication this and this is 14. A negative 14 and positive 15 is 0. Entonces, when this situation happens, it's because the factor x minus 2 belong to this polynomial. Yes, this is the remainder theorem. When the remainder is 0, it's because the factor x minus 2. Where come from x minus 2? 2 is the same 2 of this, but opposite side. So when you write like a factor, you change the sign. And when you write like a 0, no, you put x equal to. Okay, professor, but what about the quotient? This is the quotient part. The quotient part is 7 and 2. I suppose that this is x to the 0 and this is x to the 1. The actual is 2x plus 7. Wow! So we have two factors, the first factor and the second factor, and so we are doing the factorization without factorization, using just division. Cool? Do you understand or no? So far we are doing systematically the remainder theorem and using scientific division every day. And remember, if you get no 0, then this is factor don't belong to the given polynomial. So to be factor, the proof que ese factor is because the remainder is 0. The remainder 0 indicates que es a factor, and this is the remainder theorem. Let me try, this is example 1 of that part. Let me try another example to clarify a little bit. Example 2. Do you follow me or no? Totally lost? Do you remember scientific division in high school or no? No? You don't?
Nope.
No. Okay, this is new in the college. It's easy. It's super easy, I promise. Don't worry, we practice a lot of in the review and in the lectures. Suppose another example. Easy, not complicated. Suppose f of x is equal x cubed minus 6x squared plus 11 x minus 6. Okay, our problem now is find the zeros. Okay, one more time happening. Okay, the polynomial gets given in the problem is degree 3. We expect 3 zeros. I don't know if the 3 are real or imaginary or no, but 3 in total. Okay, entonces now, pero by factorization it's impossible doing this. No possible. Scientific division, yes. Let's do it. You copy the symbol of the division, and you copy coefficients. You get 1, minus 6, 11 positive, and minus 6 again. But the problem is that I don't know what number I need to put here. I want to explain after the clue to determine this number. However, I did at home. Yeah, I know very well what number work perfectly. You put arbitrary number. Yes, you put arbitrary, but there are some theorem que indicate que es a specific number. Suppose que I put 1. Suppose que you don't know the theorem, so you put 1, 2, 20, until, what is the idea? Que you get 0 here in the remainder. You get 0 in the remainder as a factor. So you don't get 0, no. Bring down 1. Bam, just bring down. 1 times 1 is 1. Negative 6 plus 1 is negative 5. And negative 5 times 1 is negative 5. And 11 positive minus 5 is positive 6. And positive 6 times 1 is positive 6. 0 remainder. Cool. Therefore, the conclusion is the factor x minus 1 belong to this polynomial, and the 0 is x equal. The question can fly in the air. Well, professor, to say I need to guess it because this number is not given at the beginning. Okay, yes, but guessing is marked. I want to explain after. My goal now is explain one more time the mechanism of the scientific division, because you definitely get the idea. Suppose in this case you have two possibilities because the degree of the original polynomial is 3, and when you perform one scientific division, you reduce this new polynomial degree 2. So this is x to the 0, this is x to the 1, this is x to the second. Actually, we have x squared minus 5x plus 6. Wow, it's easy by factorization. So basically, we are doing here a combination of scientific division and factorization. Okay, I prefer that you start doing scientific division when you reduce the degree of the polynomial. So now maybe, depending on the example, you are ready to take factorization or no. I want to explain both ways. Look, in this case, it's pretty easy. In this case, the factorization is x, 3 and 2, because 3 times 2 is 6, and 3 plus 2 is 5, and minus. And already we are doing the factorization. This polynomial is x minus 3, x minus 2, doesn't matter the order, and x minus 1. O sea, the 0, si suppose que hay listing factor, x minus 3, 0 is positive 3, 0 is x equal 3. Another 0 is another factor, sorry, is x minus 2, and the 0 is 2. I create this example to make funny. 1, 2, 3 is the factor. Suppose que you don't see very well that part. Okay, no problem. So now I continue doing another scientific division. Why not? Entonces suppose que I do the scientific division using 2. Entonces now bring down 1. Multiplication 1 times 2 is 2. Subtraction, negative 5 plus 2 is negative 3. And negative 3 times 2 is 6, negative 6. And 0 remainder again. Therefore, confirmation, the factor x minus 2 belong to this. Now, what is the last factor, professor? Oh, the last factor is x to the 0, x to the 1. So es x minus 3. Ah. Do you see the power of this? Do you understand the idea? I promise we are doing 3,000 problems of this. Okay, do you understand the mechanism? The question maybe can fly in the air is, well, no, so I need to guess in the number. No. There are theorem to investigate that. But my question now is, do you understand the idea or no? No? Confusing. Answer me, coño.
I get it.
Okay, super. Okay, so let me try to explain different way now. to estimate, remember, I want to explain two different theorems. And also we have our famous frame, que es Desmos. You are doing the graph in Desmos, and Desmos, at least you can visualize the zero real, que es the point que crosses the x-axis. Okay, let me explain one theorem. It helped me to understand and support this idea, que es the rational zero theorem. Rational zero theorem. Okay. Suppose one example. Okay, this example is nice. Let me try to explain using example. Look, suppose that function is 2x to the 4th power plus 5x to the cubed power minus 2x to the 2nd power minus 11x plus or minus, let me see. No, it's minus. Let me put it here, light, it's minus 6. Okay. My question as always, what is the degree of this polynomial? What is the degree of this polynomial? 4. How many zero we expect when you finish that? This is important property for any polynomial. The degree is equal to the solution, the zeros, including multiplicity. Multiplicity, remember repetition. You count like a twice or 2 or 3, depending on the multiplicity, and the complex. Okay, by the way, the complex always is coming by pair of conjugate. Okay, I explain in your moment in detail this idea. Okay, so what is the famous rational zero theorem? You take that formula, plus and minus p divided by q. Wow, who is p, who is q? P is 6. So it's the guy in the polynomial can have degree 0, no x. And q is this, que es the number, coefficients in front the higher. So in our example, so this is p, no? P. This is q, sorry, q. Again, repetition. P is the degree 0, and q is the degree higher. Then you copy plus or minus 6. I don't care. Okay, this is negative or positive because I included both possibility in this sign, que plus or minus, divided by plus or minus 2. So you see, one professor, this guy is negative, this guy is positive, but no, I put double sign because I need to cover every possibility. And every possibility of 6 is plus or minus 1. So you break it down in different factors. Okay, the multiplication give me 6. Let me explain how I organize this. I organize like that. 1 times 6 is 6. Is this. And 2 times 3 is 6. So the 4 possibility of the divisor of 6 is 1, 2, 3, and 6. Everyone follow me? And 2, no, 2 is easy because 2 is plus or minus 1 and plus or minus 2. So I break it down, and because I need to find any possibility. Now I create the list of the potential. It's important to say this word potential because remember we are guessing potential zeros of this polynomial. So we have, look, you take in the bottom, in the denominator, the first number, que es 1, and you divide by each. So it's plus or minus 1, it's plus or minus 2, it's plus or minus 3, it's plus or minus 6, because you suppose that you divide by 1. 1 divided by 1 is 1, 2 divided by 1 is 2, 3 divided by 1 is 3, and 6 divided by 1 is 6. And now this is the term of 2. 1 divided by 2 is 1/2. 1/2. 2 divided by 2 again is 1, but 1 I have here, I don't need to copy again because it's repetition, not important. 3 divided by 2 is plus or minus 3/2, comma, and 6 divided by 2 is 3 I have there. And this is the collection. Actually, we have 1, 2, 3, 4, 5, 6 possibility. Actually, it's not 6, it's 12 because I consider it plus or minus. Okay? Do you understand this idea or is complicated? So it's the formula. The formula is P divided by Q. Who is P? P is the coefficient of the monomial that have degree 0, so have no x. Actually, it's x to the 0, no? X to the 0, que is 1, invisible. And Q is the coefficient from the leading coefficient, que is the coefficient and the monomial that have the higher degree. And you form any possibilities of this. Now, the problem is, well, let's try to factorization this. But factorization using this new idea that we study, using synthetic division. Look, let me show you. This is the complicated part. You copy this. You copy just the coefficients in front, okay, 2, 5, -2, -11, and -6. Okay. Now, this is the challenge. What I select in this list? I want to explain, because I know the answer, idea home. And so in order to save time in the lectures, of course, I don't want to select one wrong answer that don't give me 0 remainder. So I select the answer that I verify. However, in the test, what should I do? Well. After I explain how. But you trust me, yeah, I select -1. And -1 is one guy inside the potential, -1. Yeah, I put -1 here. -1. So you select another different to -1, maybe it doesn't work. I don't know. Entonces, you bring down 2. Multiplication 2 times -1 is -2. This is 5 minus 2 is 3. Multiplication is -3. This is -5. -2 and -3 together, no? And -5 times -1 is +5. And 11, -11, and +5 together is -6. And when you multiply -6 and -1, it's +6 and 0 remains. This is the idea. When you get that, I am happy. Yeah, I can affirm that the factor and the 0, the factor is the factor x plus 1. Oh, professor, I don't understand plus. Why plus? Because it's minus. So the typical format for the factor is x minus c. If c is -1, so actually we have x minus -1. And double minus becomes positive. And the 0, no. The 0 is x equal -1 because the idea is clear. You take the factor, in our example is x plus 1, you enforce it to be 0, you solve for x, and -1. Bam! And this is, you need the difference between factor and 0, right? They are brothers, it's a similar idea, the same idea, but it's different in format. Okay, so now our given polynomial is degree 4. Now, when you are doing the first synthetic division, it's obvious that the degree now is 3 of the quotient. So I have to continue. Because I saw in one fantastic way, I want to explain after. Okay, again, I need to try -1. You say, Professor, but how do you know? Well, suppose I spend doing this problem 24 hours. I try any combination. And doesn't work, but a negative one word, a negative one again word. Let's try. How do you know the word? You bring down 2. 2 times negative 1 is negative 1. 3 minus 1, 3, not negative, negative 2. Sorry. And 3 minus 2 is 1. And 1 times negative 1 is negative 1. And negative 5 and negative 1 together is negative 6. And negative 6 times negative 1 is positive 6. Wow, fantastic. Entonces now I discover again the factor x plus 1 is a factor of the polynomial and the 0 is negative 1. But actually, in the way to do the factorization so far, we are discovered that the factor x plus 1 is twice. So you can write square like that. Well, what should I do? Two possibilities. Possibility number 1 is you take the new quotient, is x to the 0, x to the 1, x to the second. Oh, but this is easy. Because it's quadratic, and quadratic is the idea that we are doing every day in elementary algebra, factorization trinomial. Entonces, you can do that in that way. Let's do it by curiosity. 2x squared plus x minus 6. And you are doing your best. And the factorization this, remember factorization always is complicated. You try to avoid factorization, but in this case, no, it's easy. You multiply this number times this number, it's 12, and the combination can open the door for this trinomial is 4 and 3. Because 4 times 3 is 12, and somehow 4 minus 3 is 1, is this number here. Then you copy 2x squared plus 4x minus 3x minus 6. So where come from? That part. That part was 4 and 3. Okay, break it down in order to get, see, if you combine positive 4 and minus 3, give me positive 1 exactly. So we are doing anything weird. It's just substitution. Break it down. 1x like a 4x minus 3x. However, what is the advantage of this? Well, okay, you have here a couple of factors. We have a couple of factors, and you apply factorization by grouping. It's super easy. Let me show you. The great common factor in the first couple and the couple red is 2x. And so we have x plus 2, no? Because 2 times 2 is 4, and 2x times x is 2x squared. And now I do my best in the couple blue, and the great common factor is minus 3. So it says x plus 2 again, no? Because let me check it, double check it. Minus 3 times x is minus 3x, and minus 3 times 2 is minus 6. Cool. Therefore, x plus 2 is a common factor, I see. And we have 2x minus 3. Done. Factorization trinomial. Suppose that you don't like that way, or you don't feel comfortable with that way, okay, no problem. You continue scientific division. Suppose that you continue scientific division using 2. But actually it's not 2, it's minus 2, no? And the factor is plus 2. Let's bring down 2. 2 times negative 2 is negative 4. Entonces 1 minus 4 is negative 3. And negative 3 times negative 2 is positive 6. Wow, fantastic! I discovered using elementary idea that that factor belongs to the polynomial. Because I select negative 2, que corresponde with the third factor, que es x plus 2. And what is the last factor? Well, the last factor, I don't need to do anything. It's this, x to the 0 and x to the 1. Entonces es 2x minus 3. Boom! I finished the factorization without factorization, using only scientific division. Or the combination of both ideas. Do you understand or no? Maybe the question that so far fly in the air is, bueno, professor, I have a long list, entonces I I need to spend a lot of time to try -1, +1, +2, -2, +3. No. I want to explain another way. But you understand the idea? So basically we have one list. So you select this list, but I reduce the time now using Desmos. So Desmos is my friend que help me. Remember, it's important that you remember the factor. The factor is x plus 1, que actually is -1, 2 times. I suppose que the multiplicity is 2, therefore a -1, the graph is touch. And we have two more factors. Okay, by the way, I forgot to write something. So this is the factor. Another factor is, okay, let me copy. Another factor is x plus 2 factor. And the 0 is x equal -2. And the last factor is 2x minus 3. And the 0, and no idea, is 2x minus 3 equals 0. 2x equals 3 divided by 2 both sides. X equals 3/2. Okay, by the way, in decimal is 1.5. It's okay. It's x minus 3/2. Positive 3/2, sorry. Positive. That the factor is negative, but the 0 is positive. Or either way, or 1.5. And you see right now in decimals. You see it's easy. Look at that, it's easy. You take the problem, you put in decimals. You see in decimal the 0 real. Now you compute the potential 0, the list of the potential 0. And to say somehow decimal, give me a clue. What you try. Let me show you. Okay, no here. It's another folder. Yeah, there you go. Excellent. Okay, let me share the screen. Okay, switching to Desmos. Do you see my Desmos now or not yet? Do you see?
Yeah.
Okay, cool. Pay attention. Look at that. I activate that. This is degree 4. It's obvious that the aim behavior look like that. However, you determine you see. Let me make a zoom to see the graphic of the completed polynomial. I don't care that part. That part is not important. But the important for me is this point, and this point. And the 0 is 1.5, 0, que es 3/2. This is multiplicity 1, cross it. -1, multiplicity 2, touch it. And -2, multiplicity 1, cross it. Actually, we have 1, 2, 3, and 4, 0. Do you see? Okay, no, entonces no, it's not really stupid. Try another version, positive 3, 3, another number. No. You focus it in 1.5, -1. Exactly, I did -1 2 times because I saw que es touched and the multiplicity repetition 2 times and -2. More or less, you understand the idea or no? I write back to the whiteboard. I write back. I promise it's a process, little by little, you understand. But I want to explain one more important thing, que es another theorem, que help me to understand the 0 of the polynomial functions. Okay, it's about the scatter rule. And after I promise I want to do any problem que integrate everything. The Descartes rule. Okay, Descartes is the Greek mathematician. Okay, this called one rule. Okay, I want to explain right now. The rule of Descartes give me how many zeros? Positive, negative, or complex. We have looking easy. Always looking the polynomial. Suppose this example. Suppose f of x is equal x to the fifth power. Wow, degree 5 minus 6x to the fourth power plus 12 x cubic minus 12 again is a coincidence, x squared plus 11 x minus 6. Okay, degree 6. So now when I finish my problem, I suppose
Isn't
you say something?
yeah, isn't it
I don't understand.
because it's x to the fifth power minus 6.
Yeah, you're right. Degree is fine. Degree is fine. I don't know where I come from 6. Degree of 5. You're right. So now I want to explain the Descartes rule. The Descartes rule investigate the change of signs in any polynomial. Let me try to using this tool. The first monomial is positive and the second is negative. You see one change of sign. The next is positive, another change of sign. Next is negative, another change of sign. Not always happen, but in this example happen. Negative to positive, another change of sign, and positive to negative, another. In total, we have 1, 2, 3, 4, and 5. I want to call P. P. What is P? P is the number of change of sign. P is 5. So when this situation happens, I can infer that the number of positive zeros is equal 5 or 3 or 1. Where come from 3 and 1? Subtracting always 2. So you take 5 minus 2 is 3. You take 3 minus 2 is 1. And you take 1 minus 2 is negative 1. So negative 1 have no sense. And you stop in 1. But actually, Descartes say the number of positive zero of that polynomial is 5 or 3 or 1. Yeah, I need to investigate. Yes, actually, when I finish, it's 3, but it's okay. Now, what about the negative? Well, the negative, I need to make a reflection. What mean to make reflections? To make reflection means can you replace x for negative x? You make x for negative x. So now it's easy because when you change x for negative x, the even exponent stay the same. However, the odd exponent no change. Actually, this is minus x to the fifth power minus 6 x to the fourth power minus 12 x to the cubed power minus 12 x to the second power minus 11. Everything is negative. Wow. X. So you need to be aware if, for example, so you take x to the fifth power and you replace x for negative x to the fifth power, so it's like a negative 1 raised to the fifth power x to the fifth power. Yeah, I know very well that negative 1 to the fifth power is negative 1. However, in the fourth power, is different because it's negative x to the fourth power is negative 1 to the fourth power and x to the fourth power. And you need to know very well that negative 1 to any even exponent is positive. So the conclusion I did in that part was I make a reflection, because I want to investigate the negative zeros. So to make a reflection is easy. Is replace x for negative x. And when it's negative x, only affect the odd exponent change and the even stay the same. Now I come back to study the chain of sign one more time. This is a negative and it's a negative. Don't change the sign. It's flat. This is a negative, negative. Don't change the sign. Flat. Negative, 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 negative. Oh, entonces m is 0. That polynomial have no negative 0. Only have positive 0 real. Maybe 5, maybe 3, or maybe 1. I don't finish. I asked you the equation. Do you follow me so far? Do you understand the idea for the chain of sign or no?
Yeah.
Okay. Now, it's easy. It's no big deal. Now to condensing that information that look like too much, blah, 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 blah. No, it's not too much. You create a table. The table is easy. You have positive 0, that's this guy. You have negative 0, that's that guy. And negative, you know, is 0. No? You have complex. You put C, que es complex, and you have total. How many 0 we expect when you finish this problem? Bueno, the degree is 5. Entonces we have 5, degree 5, degree 5. I have here degree 5. Therefore, I suppose that we have 5 zeros. 5 zeros. So the total is 5. But when I apply the Descartes rule, I discover that we have 3 possibilities. 5, 3, or 1. However, negative no. And total is 5 always, because the degree is 5. Now the complex is coming always by pairs. Suppose another example that we see is plus and minus I, a couple, and it's coming by complex, conjugate complex. So complex conjugate. What means conjugate? Conjugate is another more complicated problem. Suppose 2 plus 3i is 2 minus 3i. So it's impossible in one polynomial, the coefficients are real. Because if you have 2 plus 3i, we have another that is not conjugate. So the complex is 2 or 4 or 6. It's even because coming like a marriage, husband and wife. And so in this case, we have no complex because 5 plus 0 is 5. Or we have 2 complex because 3 plus 0 plus 2 is 5. Or we have 4 complex because 1, 0, and 4. I want to continue this problem. And I discover, but not now, that the combination of the word is this combination. I want to practice a little bit more the Descartes rule. Well, another example. Yeah, in few seconds, on my page here, I have the solution of this problem. Okay. Let me try another example. This was example 1 of the Descartes rule. I want to do another example, example 2. Any question on the Descartes rule? You find P, you find M, you find degree. Okay. Suppose this example. F of x is equal, let me make it zoom, x cubic minus 7 x squared plus 15 x minus 9. Okay. As always, what is my equation? My equation is degree. What is the degree of that polynomial? What is the degree? Guy, are you there?
3.
3. When I finish that problem, we have 3 zeros. I don't know si this includes positive, negative, or complex. Okay, so let's do Descartes rule. Descartes rule investigate first the chain of sign. This guy is positive and this is negative. One chain of sign. This is negative, positive, one chain of sign. This is positive, negative, 2 chain of sign. Actually, P is 3. Conclusion, the number of positive is 3 or 2 or 1, sorry. Because you're subtracting 2 always. Don't ask me why. This was discovered by Descartes. Descartes discovered that you're subtracting 3 minus 2. 1 minus 2 is negative. No, entonces 3 or 1. And the number of negative, you are doing reflection. This reflection change when this odd exponent. It stay the same when it's even. Change here again, and it stays the same. Wow, in that case, it's totally no change of sign. You say, Professor, all we have in this? No. This is specific in these 2 examples. Okay, now we have no real negative. No, 0. Now we are ready to do the table. The table is easy. Plus, minus, complex, and total. You know que total is 3, no? Pero in positive we have 2 possibilities, 3 and 1. In 0, no, it's just 0. So one combination is 0 here or 2 here. Because 1 plus 2 is 3. Do you understand this?
Yeah.
Okay. So I propose you continue this solution. This is one clue can give me more information about the amount of 0, because I propose you solving this problem. This is the example 1 I am doing, completed. How? Well, you determine the potential zeros, the listing the potential 0. Maybe you put in decimals, visualize the 0 that we have, and we finish, prove me the scientific division. Okay, let's do it. Remember this. We come back again to example 1. Example 1 is P is 6. I don't care against negative, and Q is 1. The formula for the rational 0 is plus or minus P divided by Q. In our specific example, it's plus or minus 6 over plus or minus 1. So we have the factorization 6 is plus or minus 1, comma, plus or minus 2, comma, plus or minus 3, comma, plus or minus 6. It's the only possibility we have. And 1 is just plus or minus 1. Therefore, the least of our potential 0 is you take, in this case, you take this one divided by 1 by 1. This is plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. In this moment, to make fast, I put a polynomial decimals and I see what combination works. However, in this case, I don't want to do this. I want to, well, I have a table, no? Look, descartes the table. But I don't know if it's this combination. I anticipate it's this combination. Okay. Let me try to make scientific division. Okay, let's do a scientific division. So scientific division is, you copy the coefficients. The coefficients are 1 minus 6, 12 minus 12, 11, and negative 6. Let me check it out if I did well or no. I copy well or no? Oh yeah. 1, -6, +12, -12, +11, and -6. And you select of this guy one arbitrary or no. You see in Desmos the logical zero real that you have. I can see that 1 is good. And I verification this idea using synthetic division. Bring down 1. 1 times 1 is 1. And -5. -5 times 1 is -5. And 12 minus 5 is 7. And 7 times 1 is 7. And minus 12 plus 7 is -5. And -5 times 1 is -5. And 11 minus -5 is +6. And +6 times 1 is +6. Wow, zero remainder. Therefore, I discover that the factor x minus 1 belongs to this polynomial, and the zero associated with that is x equal. I promise that in a few seconds we see in this idea. One more that I saw in demo. So actually I select that guy. Now I select because I saw in Desmos positive 2. And positive 2 is positive 2 here. See what happened. So you get 0 remainder as a factor. So you don't get 0, no factor. Bring down 1, multiplication is 2, is -3. Multiplication is -6. This is 1 positive. Multiplication is 2. This is -3. Multiplication is -6. Wow, again 0 remainder. Therefore, the factor x minus 2 belong to this polynomial. And the 0 is 2. Well, okay. This polynomial is a little bit complicated because actually remember at the beginning, degree is 5. When you perform the first synthetic division, you reduce degree 4. When you are doing the second synthetic division, you get degree 3. Because degree 3 factorization is crazy, impossible. So I need to do another, okay? Of course, I did this problem easy, nice. Okay, the answer is 1, 2, 3. I select 3 now. 3, 3, 3. Let me try. Bring down 1. This is my multiplication is 3 positive. And -3 plus 3 is 0. And 0 times 3 is 0. And this is 1. And this is 3 positive. Again, 0 remaining. Fantastic. Now the factor is x minus 3. And the 0 is 3. Okay, so now I copy my crazy polynomial que es x to the 5th power minus x 6x to the 4th power plus 12 x to the cubic power minus 12 x to the 2nd power plus 11 x minus 6. I discover 3 factors. I discover x minus 1, x minus 2, and x minus 3. But we need 2 more factors, no? But this factor, I suppose, remember in the table, we see that we have 3. Positive 0, que es 1, 2, 3. No negative, no. And 2 complex. And how do you know the complex? Look at that. I take here in the quotient part. This is x to the 0, x to the 1, and x to the 2nd. Conclusion. This is x to the 2nd plus 1. You know very well that x to the 2nd plus 1 is irreducible quadratic prime expression that you cannot factorization because the solution is 2 imaginary number. And this is the final answer, x squared plus 1. Bang. Factorization without factorization using synthetic division. Beautiful. Do you see? I don't finish. I want to show you in this problem. Any question? What part you don't understand? Anything, right? It's confusing, it's clear. I promise that we are doing 1,000 problems of this. The little by little you memorize. You watching the video again? This is a moment to ask me something? No? Okay, super. Let me try. Let me show you. A ver, what example is that? It's example 11, no? Example, yeah. Okay. Do you see Desmos now? Yes or no?
Yes.
Yes. Look, I copy my same polynomial. Wow. Okay, I can see. Look, the 3, 0. Okay, put in a red color. 1, 2, and 3. Okay, here's the solution. That's it. Entonces now you can do using this character rule to do the table. Oh no, because you are smart. You copy the polynomial Desmos and you see 1, 2, 3, and you perform 3 scientific division, and you prove me that 1, 2, and 3 are 0 of the polynomial. End the story. That's it. Let me try another. Let me see what's the next. No, it's complicated. All right, let me try another. Okay, this is good. So we come back to the whiteboard. Look, let me show you. Whiteboard is this. Okay, let's do in this. Why not? The second example. Use the scientific division. Okay. We did the analysis of the Descartes. Okay, entonces the only thing you should do is plus or minus P divided by Q. Let's do it. Plus or minus P divided by Q. P is 9. Plus or minus. And Q is 1. Okay. On 9, the list of user 9 is plus or minus 1, comma plus or minus 3, comma plus or minus 3 again, because 3 times 3 is 9, and plus or minus 9. Not necessarily repeat. Divided by plus or minus 1. So now our potential list is plus or minus 1, plus or minus 3, and plus or minus 9. And these moments you want, you put in Desmos, and your verification exactly what combination it is. I did that. Actually, I did that. Descartes rule. Y I don't know si es this column or this column. You see que es that column. The 3 positive. And the positive are, let me show you. Scientific division. Coefficient in this polynomial was 1, negative 7, 15, and negative 9. Let me double check and see if I did well or not. Double checking. 1, negative 7, positive 15, and negative 9. Cool. Now, I see in Desmos what is this combination, maybe. Yeah, this 1 is good. Positive 1 is good. That guy is good. Okay, let me try. How do you know it's good? How you prove me it's good? Why not using Desmos? Why not? Or scientific division. Bring down 1, multiplication of 1. This is minus 6. Multiplication is minus 6. This is positive 9. And 9 times 1 is positive 9. 0 remainder. Okay. Therefore, the factor x minus 1 belongs to this polynomial, okay, is equivalent to say 0 x equal. Nice. Okay, cool. Entonces now I discover also que 3, positive 3, is also, okay, entonces now, well, in this case you can factorization because this is x to the 0, wow. X to the 1, x actually is quadratic. the student get preferred factorization, we can do that. Look, let me show you. And you open two parentheses, and the combination that open the door for this trinomial obviously is 3 and 3, because 3 times 3 is 9, and 3 plus 3 is 6, negative of. Wow, I discovered it's a coincidence is x minus 3 squared. The reason is because this trinomial is perfect square trinomial. So what is the final answer? The final answer is x minus 3 2 times x equal 3, and the multiplicity of this 0 is 1, therefore cross it the axis, and the multiplicity of this is 2, therefore touch it. Yes. And so what is the conclusion, Professor? One of the factorization of this trinomial that was at the beginning x cubed minus 7x squared plus 15 x minus 9 is equal x minus 1, doesn't matter the order, x minus 3 squared. Okay, see, I come back again to the Descartes rule. Descartes rule say, wow, look, let me erase that part to see more clear. We have 3 positive. And what is the 3 positive? Is 1 and 3 twice. Multiplicity 2. No complex, no negative. End of story. End of story. And this is the graph without decimals was something like that. XY. 1 0 and positive 1, 2 and 3, and 1 0 and positive 3. And the end behavior expression es x cubed, y x cubed que es exponent odd and coefficient positive, entonces the end behavior look like that. Making sense, right? Now my graph is coming from infinity here, touch 3, because multiplicity is 2. I don't know exactly what's going on here, and cross here. If you want, you can see in this one. Okay. Let's do one more example. I like this. You get the idea or not?
Yeah.
Let me try now one more example in the time that we have. It's not too much. In which you integrate everything. We integrate everything. We integrate degree. We integrate the Descartes rule. We integrate plus or minus p divided by q. We integrate decimals, and we integrate right now scientific division to discover the polynomial. And finally, we are doing approximately, the graph of the polynomial. Let me try. Let me try to find one good example. I like this. Okay. F of x. Guy, remember today at midnight, submit test and homework. I will check in tomorrow in the afternoon, because I have class in the morning. I put the point in the canvas, and we finish chapter 1. Okay, help me. What is the degree of this polynomial? What is the degree? No idea.
4.
4. Cool. So we expect when you finish this 4 zeros. The amount of zeros is equal 4. Okay, what is the end behavior expression? Remember the idea behind end behavior expression is the the dominant? Who is the dominant? Who is the monomic increasing faster than the another? Do you understand very well this or not?
Yeah, would it be x to the fourth?
Exactly. 2x to the 4th. And you infer, according to the A indivisible expression, que the hour graph look like that. Yes or no?
Yes.
Because the coefficient is positive and the exponent is zero. When you finish, you have a graph like that. Okay. I'm totally lost, but I continue. Now I go to the plus or minus p divided by q. Who is p in our problem?
-6.
Exactly, it's 6. You omit the sign because you always consider it plus or minus. And what about q? Who is q?
2.
2 plus or minus again. And their combination are plus or minus 1, comma, plus or minus 2, comma, plus or minus 3, comma, plus or minus 6. Remember, one mnemonic divide to see if it's completed or not the combination. You multiply this and this, and this and this, and the answer always give me 6. And plus or minus 1 is plus or minus 1, comma, plus or minus 2. Now the list of the potential rational 0 are plus or minus 1, you consider the first number in the denominator divided by each numerator. Como 1 is invisible, you know, stay the same. However, 2 no, because 2, consider 2 as 1/2. Is 2 divided by 2, que again is 1, is the same, is plus or minus 3/2. 3 divided by 2, and 6 divided by 2 is 3, I have this. And this is my list of the potential 0. Do you understand very well this or not?
Yeah.
Yes.
Cool. Now, I go to Descartes rule. Descartes rule, you analyze the chain of sign of the original polynomial. I copy again, one more time. Okay, I forgot x here, sorry. -6. Now, I see using recolor. Okay, this is positive, stay the same. No change the sign. Positive, negative, change the sign now here. So I indicate chain of sign using this parabola. I don't know exactly. This stay the same, stay the same. Actually, P1. And the number of positive is 1 because 1 minus 2 is -1, and -1 have no sense. Only I take the positive. In order to investigate the negative, you take the reflection of the polynomial. And the reflection, this stay the same because exponent even. This is change, exponent odd. This stay the same because it's exponent even, and this is change because exponent odd, 1, and this is 6, -6 stays. Yeah, investigate the chain of sign. Positive, negative, 1 chain of sign. Stay the same. Negative, positive, 1 chain of sign. Positive, negative, 1 chain of sign. Therefore, M is 3. Therefore, the number of negative is 3 or 1, because 3 minus 2 is 1. So we are ready to summarize this information and the famous table que Descartes created for this condition. Positive, negative, complex, and total. Total is obvious que es 4. And positive, we have only one combination. But negative, we have 2 combinations, 3 and 1. And this is, I repeat 1 because 1 is only possibility of positive. Entonces, complex would be 0 here. Remember to complete the 4. 3 plus 1 is 4 plus 0. And here is 1 plus 1 plus 4 again is 2. Actually is, we have 2 possibilities. 1 positive real 0, 3 positive no, negative real zero and no complex. When I finish, I promise is this possibility. No. I need to investigate, put in decimals, apply scientific division several times. Let's do it quickly because we have only 5 minutes to finish. Okay, this is, I create the format for the scientific division. You put a coefficient, it gets 2, 5, minus 2, minus 11, and minus 6. And you, in decimal, well, no, in the list, on decimal, I take negative 1. Negative 1. Negative 1 belong to that list. Where? Here, over there. Negative 1. Now remember, you take arbitraries, but in order to save time, I take the thing I try, I prove. How? Bring down to multiplication, negative 2. Is 3. Multiplication is negative 3. Combine is negative 5. Multiplication is positive 5. Is negative 6. Multiplication is positive 6. Zero remainder, therefore the factor that we discovered, we proved, was x plus 1, opposite sign to this, and the 0 is negative 1. Another factor que I investigate is again negative 1 because the multiplicity 2. Bring down 2, negative 2, 1 positive, multiplication of negative 1, and negative 6 multiplication of positive 6. Nice. Is the factor is x plus 1 again, x equal minus 1. And when you are doing the factorization, you need to write x plus 1 square, multiplicity 2. And now I have, well, I don't know if I continue doing scientific division or no. The student can prefer isolate that part, x to the 0, x to the 1, x to the second, actually is 2x to the second plus x minus 6. Just doing the factorization is 12, 3 and 4 again is similar. This is 2x squared plus 4x minus 3x. I put in corresponding order 4 minus 3 is 1, minus 6. And you apply factorization by grouping, GCF that part, GCF that part. Entonces es 2x, x plus 2. And the great common factor is minus 3, x plus 2. X plus 2, 2x minus 3. So now the total factorization for this polynomial was x plus 2 and 2x minus 3. This is equivalent, 100% equivalent, perfect to this polynomial. Let's do it quickly, the graph. The graph look like that. This is the x-axis, and this is the y-axis. The 0, que is the most important, lie in negative 1 here. Multiplicity 2, therefore touch. Another is a negative 2, this is negative 1. And negative 2 is multiplicity 1, cross. And the last one is 2x minus 3 equals 0. Es obvio que es 2x equal 3 es 3 half, que es 1.5. O sea, dice 1, dice 2, and the middle is 1.5. 3 half. The end behavior is like that. This touch, okay, across, sorry. This touch, and this is cross. And corresponding perfectly with this idea of the end behavior. You get more or less the rough idea for this?
Yeah.
Cool. So we finish polynomial. Next time we start a new section. Okay? Okay, bye. Bye, guys.
Professor, question.
Go ahead.
When I was taking the test, I got a percentage that I'm like happy with,
and it's making me like retake it, but I don't want to retake it again.
And you can. You say the reading or the online?
The online.
No, online is also available. Yeah, I give 4 attendance.
Yeah, but I don't want to do it again. I want to leave it like that because it took me a long time, and I want to leave it like that, and now it doesn't let me. Like it tells me that I have to do it again.
This is weird. This is weird, miss. You email me to understand what's your name. And so I checking. I go inside in my computer of the Alex. Yeah, I verify your idea. If you want, I can extending or I can give it another attendance.
Oh,
How many times you take? One time?
One time, only one.
No. I put available 4 times.
Oh, okay, but it doesn't let me continue. I didn't finish one of the homeworks, and it doesn't let me continue either.
No, the homework is unlimited. You take one
But
time.
it doesn't let me. No, it doesn't let me continue. When I put to do it, it doesn't let me.
Oh, maybe it's one setting that I need to fix it. Pero Isabela, just in case you email me to remind me, because I go to another lecture now in the campus, you know? Because you email me. I fix it today. Okay. Before midnight. But don't worry, si you need more extension, I do the due date for Wednesday or whatever. But we negotiate. It's important communication between us. Okay?
Okay, thank you.
Bye-bye. See you.